The ultimate counterfeiter isn't a crook. He's a consummate artist. With painstaking precision, his execution is nearly flawless, down to the smallest of details. Color-shifting pigment on crisp U.S. bills, a faultless visor emblem or logo for Louis Vuitton. Fueled by easy internet sales and global supply routes, bogus goods are a booming business. One costing government and private industry billions annually, while posing a host of other national safety and security concerns. But as counterfeiters grow in sophistication, so too does security technology. Graduate students like Jeevan Maruga are developing security printing and anti-counterfeiting technology to make forgery a nearly impossible crime.
So this is about security printing, product authentication and stuff like that. And the reason why I chose this university is like it has all these ray machines that I can work with, and that's very helpful for my research. It's one of the major problems right now because the U.S. alone annually loses about $250 billion because of that, and 60 to 70,000 jobs. So it's a major part in the U.S. economy.
That real-world application is a hallmark of materials engineering and science research, where students and faculty like Christian Widener bridge the gap from the classroom to the boardroom.
What you find is in industry they know the problem. In the university we know the technology, but there aren't a lot of places that are kind of working on, but how do you properly apply the technology to a particular problem? And so that's one of the significant areas of research that's happening here, and it's one of the reasons why the school is been able to retain funding for these areas as well.
The Composites and Polymer Engineering Lab alone houses more than $10 million worth of equipment critical to developing thermal insulation composites for space habitats, among other pursuits. While the Direct Write Laboratory possesses the capability to print on photovoltaic cells. Widener oversees the Arbogast Materials Processing and Joining Lab, fostering technologies ranging from cold spray and laser powder deposition to friction stir welding and pulsed fusion for a clientele of industry elites.
We support a lot of very large corporations, General Motors, Boeing, Moog, Sikorsky Helicopter, large corporations that are interested in these technologies have come in and partnered specifically with the lab here. And one of the things that we've done, for example, is repaired aircraft panels for B-1 aircraft out at Ellsworth.
With an ever-growing clientele and a range of research from metals and composites to nanoscale materials, the only thing to expect is the unexpected.
There's going to be some new equipment and there's some new problems and new processes that arise every day, even for somebody who's been around for years and years. The program is open for your interpretation of what's going on, and you really have to step up in there and figure it out for yourself.